In the last video, we went over the process of using the normal probability distribution as an approximation for the binomial distribution. And as we were going through that process, it should have become apparent to you that using the normal distribution is a much cleaner way of doing the probabilities for sufficiently large values of n and wide ranges of x. Now, if we were going to use a different distribution, how could we use the normal probability distribution to estimate that? We would first need to assess if that distribution was approximately normal. So if it's not binomial and it's not normal and it's just some random distribution that you're given, how can you approximate it to see if it's actually a normally distributed random value? To do that, there's a 4-step process that you have to go through. First, you construct a histogram to see if the shapes match. This should be pretty obvious. You just try to see if the shape of the histogram looks normal. We compare it to our 68, 95, 99.7 rule just to see if our probability lines up with that 68, 95, 99.7 rule. The third step is to find the IQR and divide it by our sample variance and see if that's equal to 1.34. So remember, our IQR is just our Q upper minus our Q lower. And then we divide that by our sample standard deviation of S. So our Q upper was the median of our top half of our values, and our Q lower was the median of our bottom half of our values. So we just need to use this value to determine if it reaches 1.34, if it's equal to 1.34. And if it is, we proceed to the final step, which is to examine what's called a normal probability plot, which is essentially the rank of the value. So the lowest value would have a rank of 1, the highest value would have a rank of n, and then it plots that versus the expected z-score. So if the data was normally distributed, we can figure out what the expected z-score is of each of those values, and we can use that to create what's called a normal probability. Since this is a relatively straightforward process, I'm just going to give you an example of what a normal probability plot or a normal QQ plot should look like. If our data is actually normally distributed, we should just get a straight line that has a relatively even slope as we go throughout the process. So since this is just a scatter plot, if it is normally distributed, it's going to look something like that. It might have some slight variations. Some of these values might be a little higher or a little lower, but it should be a relatively straight line throughout the whole plot. If instead our plot has a different shape, say it curves one way, or it goes up and then back down and then goes up or something like that, if it's sufficiently out of that range of a straight line, then we're going to consider that not a normally distributed random value.